This is problem number 63. We're going to go through A, B, and C. These are your typical area problems, finding the area of a shaded region. And these can be kind of difficult, but really not too crazy hard. So we're going to make this really big so it's going to be easy to see what we're doing here. But I'm just going to write this one time, and then we're going to do this for the next couple too. But the area of a shaded region oftentimes is just going to be the area of the total figure. Okay, when you talk about total, you talk about the entire boundary of the shape. And then you're going to subtract out the area of the unshaded part, okay, which is, in this case, a circle. So in this particular problem, this is going to equal the area of the equilateral triangle. And I know it's equilateral because I can assume regular polygons. And then this unshaded is going to be the area of the circle. So I need to figure out some things. I know the area of an equilateral triangle has a certain formula, which you can put on your little card. It's side squared root 3 over 4. And then the area of a circle has a certain formula as well, which is pi r squared. So I need to figure out, basically, I know the side is 10. So what I have to figure out here is what's the radius. And that's the hard part, because that's going to tell me the area of the circle. So before I even go further trying to find the radius, let's just figure this out. So the side of the triangle is 10. So 10 squared root 3 over 4 gives me 100 root 3 over 4, which gives me the area of the total thing is 25 root 3. If I can figure out the radius of the circle, I have the area of the unshaded, which is going to tell me the area of the shaded, which are these little sections here. So what is the radius? Well, you know something about an equilateral triangle in this problem, and that is that when you draw the apothem of that triangle, that's actually going to be the radius of this circle. You also know that equilateral triangles break down nicely into 30, 60, 90 triangles. So this triangle I just drew right here actually is a 30, 60, 90 with the long leg of it, this angle being 30. We can see that because the angles in a equilateral triangle are always 60. But when I cut that in half, it's going to be 30. So I have the long leg of this thing is 5, or half of 10. So when you look at this, this will be 5 and 5, right? Meaning you cut that 10 in half. So now I got the long leg is 5. I need to find out the short leg. Well, if I go long leg to short leg, I have to divide 5 by root 3. That's just rules of 30, 60, 90 triangles that at this point should be easy. So that doesn't break down nicely, but that's your radius. So therefore, when I go to my problem now, and that's going to be, so this is 5 root 3 over 3. That's the radius of the circle. That was the part that I needed to find. So 5 root 3 over 3 squared. This is going to be 75 over 9. 5 root 3 squared, you distribute the square to each part. 5 root 3 squared is 75. 3 squared is 9. That reduces again into 25. So 3 comes out about so each. So it's going to be 25 pi over 3. And that's all I can do. I cannot combine those. You can make it into a decimal if you'd like, but leaving it like this is actually a preferred way. 63b now is a similar problem. You got a triangle, but instead of the shaded part being the corners, the shaded part's in the middle. And basically what you got here is the area of the shaded is going to equal the area, again, of the equilateral triangle minus the area of these little pieces. These are your unshaded pieces. Well, these are sectors. Right? When we think about sectors, we think about pi pieces. So it's the area of 3 sectors. Well, we know some things about equilateral triangles that tell us what's going to happen here. So you know that this is 5 again, which is like basically the radius of a circle containing this sector. You also know the angles are 60 because it's an equilateral triangle. So you got 3 sectors, all have a arc measure of 60, and all have a radius of 5. The area of an equilateral triangle, just like last time, is always going to be side squared root 3 over 4. The area of 3 sectors is going to be 3 times the measure of the arc over 360 times pi r squared. Right? The area of one sector is the measure of the arc. So what I end up with here is 10 squared root 3 over 4. We just did this one. You know it's going to end up giving you 25 root 3. This is the part that's a little bit different. So 3 times the measure of the arc. So 3 times the measure of the arc, 60 over 360 times pi radius 5 squared. So what I basically end up with here is 3 times 60 is 180. So this ends up giving me like 180 over 360, which is actually half of a circle. So pi times 25. So what you basically end up with here is 25 root 3 minus half of 25 pi, or 25 pi over 2. And that is the area of the shaded. And again, we're talking about area, so all these are units squared. Okay, square units. 63C is the last one we're going to talk about. And again, the area that we're looking at, the area of the shaded, is going to be the area of the hexagon minus the area of the circle. Well, the area of the hexagon is a formula. It's going to be 1/2 apothem times perimeter. The area of the circle again is pi r squared. If we knew again, like the first question, not this one, but this one, the problem, the apothem of the equilateral triangle right here, you can see that the apothem actually was the radius of the circle. So that's going to be actually true again when we talk about this problem. The apothem of this hexagon is actually going to be the radius of the circle. So in a hexagon, we learned the apothem is always half the side root 3. We can always break it down into your equilateral triangles and your 30, 60, 90s, but it's just something that you probably caught on to by now. So the apothem is 5 root 3. So that's actually going to be the radius of the circle. So this is going to be 5 root 3 squared. That's also helping me with the area of the hexagon, because if the apothem is 5 root 3, I already know the perimeter of a hexagon is 6 times the side length. So in this case, it's just 60. So 1/2 apothem 5 root 3 times the perimeter 60 is the area of the hexagon. I'm going to subtract the area of the circle, which is pi 5 root 3 squared, because the apothem of the hexagon is also the radius of the circle. So this is what I get. Half of this is going to give me 150 root 3. 5 root 3 squared, we just did in the last one, was 75. So this gives me 75 pi. Again, we're talking units squared. All right, that was problem 63. I hope this helps you.